Welcome back. More complex counting problems. In BASIC, the name of a string is one or two alphanumeric characters, only one or two, where uppercase and lower cases are not distinguished. Moreover, a variable name must begin with a letter, and there are 5 strings that are reserved for programming use. How many different variable names are there? Okay. Variable name has one or two alphanumeric characters. So we first count number of one character names. The variable name must begin with a letter. There are 26 possibilities here because it's only one character. So that has to be a letter. Now count the number of two character names. Variable name must begin with a letter. The second character can be a numeric or alphabetic. 26 letters and 10 digits, in all 36 characters. So the number of two character names are 26 times 36. Finally, there are 5 strings which are reserved. So in all, you have 26 one character names, 26 times 36 two character names, minus 5 reserved. Assuming my calculation is correct, 957 number of names. Each user on a computer system has a password which is 6 to 8 characters long. Each character is an uppercase letter or a digit. Each password must contain at least one digit. How many possible passwords are there? Alright, each password has to be 6 to 8 characters long. Each character is an uppercase letter or a digit. Each password must contain at least one digit. So for 6 character long password, you may have only one digit and 5 letters. That's 10 times 26 to the power 5. Or you may have 2 digits and 4 letters, 10 to the second power times 26 to the fourth power. Or 3 digits and 3 letters, 10 to the third power, 26 to the third power. 4 digits, 10 to the fourth power, 26 to the second power. 5 digits and 1 letter, 10 to the fifth times 26 to the first, or all 6 digits. Likewise, so therefore number of 6 character passwords is, add all these numbers up. Similarly, you may count number of 7 character passwords. That's 1 digit, 6 letters, 2 digits, 5 letters, 3 digits, 4 letters, so on until all digits. Likewise, 8 characters. So total number of possibilities, add them all up and assume my calculation is correct. Now, this is perfectly fine, but there is a much faster way of addressing this question. Digits and alphabets together are 36 characters in all. Our passwords are not allowed to be all letters. So number of 6 character password is 36 to the power 6 minus the possibility that they are all letters, 26 to the power 6. Number of 7 characters passwords, 36 to the 7th power minus 26 to the 7th. 8 character passwords, 36 to the 8th minus 26 to the 8th power. So add them all up and that's your number. Okay. Internet. In the internet, each computer is assigned an internet address. In version 4 of the Internet Protocol, IP version 4, an address is a string of 32 bits. 32 bits is 4 bytes. It begins with a network number, that is a net ID, and the net ID is followed by a host number, which is a host ID, which identifies a computer as a member of a particular network. 3 forms of addresses are used, with different numbers of bits used for net IDs and host IDs. Class A. addresses are used for largest networks consisting of 0 followed by 7-bit net ID and a 24-bit host ID. Class B starts with 10 and then a net ID which is 14-bit followed by a host ID which is 16-bit. Class C consists of 110 followed by 21-bit ID, net ID, 8-bit host ID. There are several restrictions on addresses. 11111 all ones is not available on Class A network, net ID. And host IDs consisting of all zeros or ones are not available in any of the network. How many IPv4 addresses are available? Well, let's look for Class A. 2 to the 7th 1 minus 1. Why? Because net IDs, there are 7 locations and you are allowed 1 and 0. So 2 to the 7th, but you are not allowed all ones. Host IDs, there are 24 locations. 2 to the 24 minus 2. Why 2? You have to subtract the possibility of all zeros and all ones. Okay, so that's for net ID, host ID for Class A. So multiplying the 2 gives you number of Class A addresses. Likewise for Class B addresses. You are allowed a certain number, 14 places for net ID. That gives you 2 to the 14. And host ID, 16 places. 2 to the 16, but remove the 2 which consists of all zeros and all ones. Total number of Class B addresses are 2 to the 14 times 2 to the 16 minus 2. Lastly, Class C. There are 21 locations here for the net ID, 2 to the 21, and 8 locations for the host ID, and remove the 2 corresponding to all zeros or all ones. So this times this is the total number of Class B addresses. So all of the total number of IP addresses are Class A addresses plus Class B addresses plus Class C addresses. Note there is nothing common in these addresses because net IDs begin with 0. So no net ID will show up in B and C. B ID begins with 10. So no B ID will show up here. Okay, so they are all disjoint collection of IDs. Okay, so that's why you can safely add them up. Okay, so let's continue the subtraction rule in our next video.